Hello, hello, hello. My name is Mofi, and welcome to Twitch Stream Thursdays. I have
Nick.
here with me. Nick, do you know what we're talking about today?
Probably not Docker, maybe Kubernetes.
Yes. So last week we kind of like closed down our Docker learning, right? Like we had pretty good understanding of Docker. We know what Docker is, how Docker works underneath even. Which is, a lot more in-depth than most people kind of need to get into.
I'll still probably write a really bad Docker file.
You probably will. That's fine. It's a learning process, right? It's more of a, as you say with AI, it's more of an art than a science, which is not true. This is actually a science. You can actually write a proper calculated Docker file that is the best possible Docker file for your need. But still, it's just like you use it, and as you use more of it, as you read other people's Docker file, you get better with it. But I think just Docker itself can't really give you all the things you want from a cloud native application. And that's where newer things like Docker Swarm, Mesosphere, Kubernetes, the one we're going to talk about today, came in and gave us some solutions. But before we talk about the solutions, I think it's easier, it will be better for us to understand what the problem was, for us to rather than just telling you what the solution is, right? Let's also,
I didn't even realize we could be using Docker as like our web service, but I guess we did kind of with your Fox RAM.
Right.
Yeah.
So again, I don't think Docker itself takes any particular decision about what it would be running your application, right? Docker just package an application. The way we run it, it's kind of left up to our own. So I'm also like starting up. I'm gonna connect my iPad so that we can do a little bit of writing, a little bit of drawing. Why should you and AI have all the fun? Our cloud native things need some fun as well. So
now I get a chance to make fun of your handwriting.
You do get the chance. That is true. Oh, I should do it here. 9759. Excellent. And I'm gonna switch my screen, which I have done so, and I'm also gonna kind of slide it on this corner. Excellent, not blocking any view. Very good. So, I mean, if you have deployed any applications before the Docker and Kubernetes craze, or if you had access to any of the servers, or use the Raspberry Pi to deploy an application, you know this thing. And this image, Google says is a server. I'm going to take Google's word for it. This probably
looks like a nice box.
It's a nice box. Like it's a black box that runs a computer that you have access to. And to this day, this is probably the most used solution for people deploying application. This is one solid computer. It could be a bare metal, or it could run other virtual servers in this thing, and each virtual server will run one application. Works pretty great if you don't have too many applications. For example, your cloud annotations application is just one application, one front end with the back end kind of compiled together itself. This is actually pretty great solutions for that, right? Like you run your application. Some people people actually found solutions to have the self restart. They ran another daemon on the server. They constantly look for if the application is running. If it didn't run, it just spawned up the application back again, right? For updates, people could use something like a cron job every Thursday or like every Friday night at 12 p.m. Just start a cron job, do the update. Friday night, yeah. Or like Monday morning, I don't know, when you want. It doesn't really matter when you do it. It just like depends when you want to take the hit. That's what matters most, right? So
on the weekend.
On the weekend, of course. That's when you want your SREs to be up, all that. But like you could do all that thing, right? And so you have your application. You basically, if you are doing Java, you create your fat jars, create some sort of pipeline to get this uploaded to the server, and the server just runs the application. You have some sort of load balancer on top. People can come access your application, if it's a web app, that is. And this works. This works for the most part. And to this day, again, this is the most used way people deploy their application. But the problem starts where you start thinking about breaking your application down into microservices. Having a VM, although you want a VM to run for a long time, but the promise of a microservice is that you're going to run your application very fast, it's going to die very fast, it's going to spin back up very fast. VMs are not meant to do that kind of things, right? Like, because it's a full OS that has to spin up, load all these files, blah, blah, take some time. Docker, on the other hand, can run in microseconds, milliseconds. It's very fast. This, we are counting time in seconds, if not minutes. You're saying my VM come back in 3 minutes. If your application is down for 3 minutes, again, it might not matter because it could be one of those applications that not always being used that much, or it's using long-running jobs. As long as you can get back those jobs, you are just fine, right? So for the most part, you probably don't care if it's running on VM.
Okay.
The places where you would care, again, when you're using microservices, we have 10 of the services running at the same time, and one service depends on another one. So I'm going to go to the next page. I'm going to have the picture of Docker because I didn't want to draw the picture of Docker. We have tried drawing it on the wall. Didn't work that well.
You're pretty good at drawing a Docker photo.
Yeah, given enough time, but I didn't want to do it live. It was just, okay. So basically, now you have a bunch of this application, and some of them may have multiple copies. Some of them may have even more copies. And all of them are basically talking to each other now. Like this one is talking to this one is also talking to this. Let's say there's another application that basically this one talks to, right? And you have like this big chain of things.
How do you get Docker containers to talk to each other?
So again, when we talked to our Docker container, it all had like this IP addresses, like localhost :8080.
Okay.
And from your host machine, you could open up a port. You could say, although inside the Docker container we're opening up port 80, from my local host I'm going to open port 8081. Then for the next one I'm going to open up port 8082, so on and so forth, right? And you're basically talking to each other over network, right? But what if this one goes down now? Although it's a small application went down, this one actually takes down this application and this application now, because this one has nothing to do other than this one calling it, and this one can't do without calling this one. So I'm gonna, actually I just realized I was pointing with my pen, no one can see it. So this, I erased it. Excellent, I need this. So this one needs this one to function, and this one like does nothing but give information to this one, right?
Right.
So in this situation, if this if this one goes down and is down for like say 3 minutes, that means for 3 minutes, 2 other applications on your system couldn't do anything. For this kind of things, very fast turn on is very actually important, because you don't want 2 of your other applications that didn't actually die to do nothing for 3 minutes. That's where Docker actually becomes super useful. Docker does this thing really well, where because it's so small and such a small package, it can spin something back up in milliseconds. We tried like running Docker applications. We saw if it had the image stored locally, it could just spin something up just like that. If it didn't, it still would download it. But even the download, because it's so small, 20 megabytes can download in less than a second.
Right.
Right. So we got the point of Docker. We looked at how Docker works, how Docker does everything. But the places Docker kind of has some struggle is that Docker itself doesn't really know what else is out there, right? Docker is just basically, I'm this container, I ran this container, and that's pretty much it. I don't know anything else that is happening around me. You could, as an operator, make sure that Docker, like you could make call to port 8081 there, port 8082 there, but Docker only knows about individual containers. So Docker doesn't really have like overarching view of it. Docker also don't really know about how much resource overall it has. It can limit resource on individual containers, but doesn't really know how much resource over the host does it have. Gotcha. That's where I think this little thing comes in. So Kubernetes, if I had to like give one word definition of Kubernetes, it's basically, so it's I'm just looking for like this one sentence answer for what Kubernetes is. I would just say Kubernetes is just a scheduler that controls resource. So why do I call Kubernetes a scheduler? So in the heart of Kubernetes, what Kubernetes does is, given your application and how much you want, how many copies of application you want to run, Kubernetes tries to figure out the best possible schedule to place these things. So in Kubernetes world, what you have a bunch of these things called nodes. We talked about nodes before. But think of node as, again, back to your virtual machine or like a bare metal or your Raspberry Pi. Node is something that can run some compute job, right? And you can have many nodes, and the node doesn't have to be homogeneous either. It could be literally any kind of mix of things. You can have nodes with a lot of RAM. You can have nodes with a lot of CPU. You can have node with a lot of space. So based on all those things, you can have different kinds of nodes. So you have, let's say we have a cluster, let's say with 3 nodes. And each of those nodes...
Is that not 4?
Oh, 4. Here you go. We have a cluster with 4 nodes and a master. And this master has a bunch of other things. It has a scheduler in it. It has API server that gives you, the user, access to all these things via some API calls rather than you having to manually tweak these knobs.
So does this master require like a separate node, or is it?
So master is a completely separate node, yes.
So then we have 5 nodes now.
And if you want to get high availability, you actually have more than 1 master.
Okay.
So then you have 3 or 5, always an odd number, because that's where, the reason you do odd number masters is because masters, when they have to decide which master is right, you have to do some voting, and you don't want even numbers because then you end up with 2 and 2. Okay. Or like 1 and 1 votes. That never works out. So you always just do like odd numbers, because you have odd numbers, you're always guaranteed that you're going to have a nice vote.
Gotcha.
So we have 1 or more masters, 3, 5, 7, whatever odd number you want to go for. And the master have, every time in the masters, they automatically elect a leader. And the leader's decision is kind of like the last final vote to cast. But again, don't worry about that for now. But you have a couple of things. You have a scheduler, and you have API server, and scheduler is the one that knows exactly how much resource it has available. And each node has something called kind of like a daemon that's running. It's called a kubelet. And the kubelet is the one that's talking to the master at all times, giving information about the node. It's telling, oh, I have 4 gigs of RAM left. I have 25 gigs of space left. I have 2 full vCPU left. vCPU is a virtual CPU. Master scheduler then knows exactly how much stuff they have left. And given all the things they have left, it can then start scheduling things when a new job comes in. The way you basically access your master from a user's point of view is using either the CLI or the web terminal, right? And the CLI is called kubectl or kubectl or kubectl. And one joke I tell people is that no matter how you say it, you are wrong. Like there's like 4 or 5 ways people call this thing, and I feel like everybody's wrong. There is no right answer. It's just like one of those not answered question in computer science. No, but like again, call whatever you want. For the most part, in my computer, I actually alias it to KL because it's easier. So kubectl is a CLI tool, but it underneath wraps the API call. And the API call is basically calling to your master server and asking for what do you have, like what can you give me back. We're going to take a look at that, like what kind of calls we can make in a second. But the point is, the kubectl is basically just wrapping your API calls and using like certificates to be able to access your master. So a little bit about the nodes. So the nodes have like limited amount of resource, right? Like it has all this resource. And based on how much resource it has left, the scheduler can then label a node not schedulable anymore. For example, if it has like very little amount of resource left, scheduler will no longer schedule anything on top of that. There are certain times what happens is, if let's say you have a node, but that node have some other resource already installed in it that is not being reported by the kubelet, what could happen is that the scheduler thinks it has like a gigabyte of RAM, but in reality it only has say 200 megabyte left, because the other 800 megabyte is being used by some other application that's running on the node but not being reported by the kubelet, which is possible. That can happen. So scheduler then will try to schedule something there, but it will just fail because it doesn't have enough resource to do what it wants to do. Next up is inside node, you have the smallest possible thing you can run on Kubernetes is called a pod. And we talked about pod before.
Yes.
But I think given last week when we talked about how a container actually work, we can actually dive a little bit deeper into how a pod actually works.
Okay.
Because we know a pod is a collection of containers.
Oh, it's a collection of containers. I just figured it was a container.
No. So if you, let's say, if you draw a pod just like this, and you can have actually more than one container. Most of the time, you'll only see one container.
Okay.
But in some advanced cases, or even some useful cases, you'll see more than one container jammed into one pod. So, like, you might be wondering, why not just use container as the lowest, like a unit of smallest unit in Kubernetes? And I think it would be a good question to ask, like, why not? But I feel like using a pod instead of a container as the smallest unit gives us some added benefit. For example, you could do things like init container that can do certain work before your container starts up. So you could do some management work. For example, you want to set up a database or download some files, copy some things over. You could do that before any of your containers start. Otherwise, you would be doing a lot of things in your code, in your application code, that doesn't necessarily concern anything with your application. So
Gotcha.
Init containers are pretty good at that. Sidecar is another pattern people use where you have two containers running side by side, and one container is your application, other container is things your application need, but not necessarily something your application needs to do itself. Like, for example, the biggest example of that is the service mesh architecture people are using for Istio, Linkerd, all that stuff. What they do with the sidecar uses IP table rule to capture network calls coming into your container. And then it can do some metric collection, some header checking to like finding version and things like that. And
Gotcha.
doing that in your application would require a lot of code changes. Like every new version, you'll have to add a new logic to your application. With Sidecar, you can just extract that out on the sidecar, which you can easily change without having to change your application code.
Gotcha.
Makes it pretty like plug and playable. Like your application will do exactly the same thing over and over, but you can change up the sidecar to keep swapping out like underlying business logic a little bit. For example, let's say another pattern you can use. Let's say you have a database connection, and you don't want to hard code the database connection on your application for various reasons, for testing. One thing you could do is like say, oh, this is my this like flags like a production. If environment production, then use this database connection, versus if it's test, do this. If it's staging, do this. Instead, you could swap out sidecar containers that holds the production secret or the staging secret, and from your application, you're just calling localhost, right? And underneath, it just does the right thing. But how does a pod then do what it needs to do? So we remember containers, and containers has these things called namespaces, and then things called C groups, right? When you have pod, it's like such a simple idea, but what it's doing, it's saying, let's say I have one container, and the container has all my namespaces set, right? I have my UTS, Unix timeshare, then you have user namespace, you have regular just namespace as they call it, does the mount, right? Then you have network namespace, and like a couple more, and you have all the C groups. When you want to basically create a pod, what Kubernetes does underneath, it says, I have this another container, and this container should just use the namespace of the other container. So in a pod, although I drew a box just like around the pod, in reality there is no box. Like we just lie to ourselves and everyone else so much. In reality there is no box. We're just saying this container A has this namespace that I set, and let container B just use the same namespaces. So from the point of view of the container, these are the two processes that exist in the world, because everything is isolated. Remember from last couple of weeks ago?
Yeah.
Everything else is isolated. So from the point of view of these two containers, it knows there's only one network protocol, this one. There's only one namespace. There's only one mount. There's only one user. There's only one Unix timeshare. So this process could be running anywhere on the host. But since we use the same namespace, they kind of work together.
Gotcha.
So although we will draw this box just to make it easier on ourselves, you now know underneath there is actually no box. It's a lie. There is a great talk, or like there's a couple of great talks and a couple of great articles. I think it says container is a lie. It's a great talk. I had a chance of like seeing the talk live, like when I was giving it. I totally forgot his name. This is so sad. Anyway, if you just Google Container CLI or like on YouTube, you'll probably find the talk. It's really great. But the point is, again, although it's a lie, it doesn't really matter for your point of view. You just want to create a pod. It's great. You can put multiple containers in there or init containers, everything you want to do. So that's what pod is. But pod by itself is still not doing anything useful yet, because all the promise of Kubernetes, we're still not getting anything. Because pod basically just runs, and if a pod dies, just like a container, it just dies, nothing else happens. But in Kubernetes, we're supposed to have auto self-restart, right? So that's where our replica set comes in. So our replica set, oh, I forgot also, master has the API server, the scheduler, and the etcd database. So the etcd database job is to keep track of the state of the cluster. What do I have? What do I want to have? All these things. Also, you store the secrets. Another thing about Kubernetes, the secrets by default are just base64 encoded. So don't store your password in Kubernetes just by default. Just try to do a little bit more research how you want to store your password. We have another whole talk on how to store secrets, but for now, if you're using it, be careful. So replica set. So replica set uses etcd to keep track of how many copies you should have. So let's say your application, you want to run 5 copies of it, and you say create 5 replicas of it. So replica set will have number 5 there on etcd, and then the scheduler will then look at the etcd database and say, you know what, I want 5 copies of this. As of now, I have 1. That means I need
4 more.
Right. So another thing about Kubernetes, it's not imperative, it's declarative. So you declare you want something. In an imperative system, for example, a language that is synchronous, you try to do something. If it doesn't make it, it will get stuck there, right? Or fail, or like crash. But Kubernetes doesn't do that. Kubernetes just says, I want 5 copies, do what you need to do. That's why when you write a command in Kubernetes, it just like comes back to you, success. But then the API server then, the scheduler then says, oh, I need 5. I have only resource for creating 3. I'll create 3, then wait for more resource to be available. So sometimes if you want to create, let's say, if you just go to your cluster and say, give me 10,000 copies of this pod, your command will actually not fail. It will actually come back as a success. But then the API, like scheduler will try to create 10,000 copies, will probably be able to create like 100, and then just get stuck on pending forever. But the thing is, on the meantime, you can keep doing other things because it's asynchronous from your call, which is pretty great. Also sometimes problematic, because if you're doing some automated work, you sometimes don't know if it succeeded. So you have to like keep like pinging to see if 5 copies became available. So it's a double-edged sword. It's pretty great because it never gets stuck on you. It just gives you data back and eventually makes it happen. But the problem is if you're trying to automate, for example, if you want to, I don't know, test on staging, that you want to like, oh, this command succeeds, give me 5 copies, then I can ping it, whatever. That you don't know when to start pinging because you don't know when that 5 copy became available. So you could play with it, you can figure out what is the best way to do it. But I feel like this is still pretty great because it's async. So replica set knows it needs 5 copy. For some reason, if let's say a node dies, one of our 4 node dies that had 2 of the copies running, now all of a sudden etcd looks at it, how many copies I have, it has 3 now. Now it needs to spin up 2 more. It will just, scheduler will then look at the other nodes and see, you know what, I have, this node is gone, but I have 2 other nodes that had space to do it. I'll just schedule it there. So replica set is pretty great, but in like practical uses, you'll probably never use a replica set to do your work, mainly because there is a better primitive in Kubernetes for doing this kind of things, and that is called a deployment. You have heard of deployment before. I think you use deployment, not a replica set.
Okay, yeah.
Right. So
deployment has replicas.
So deployment is kind of like the overarching structure that encapsulates a replica set.
Okay.
So So this is your pod. Let's say a pod. Pod has multiple containers. Then you have a replica set that knows how many replicas should you have. Overarching that, you have a deployment. I feel like I'm drawing like one of those chemical elements, like, like electron and all this. No, but like deployment, then the reason deployment is better than a replica set, deployment also has control over how to deploy this thing. Should be rolling? Should it be just switching? Or, so you can have a little bit more control of how you deploy. For example, with rolling update, you can do things like, let's say I have 5 copies of my application and I want to deploy to the new version, but I don't want my application to never go below 4 copies. So what do you do basically? You start deploying them and never more than 6 copies either. So what you do is spin up a new copy of a new version. So I'm going to use 2 colors. Let's see. So let's say I had 5 copy of version 1. And I'm deploying version 2. I spin up 1 copy. And now I have 6 total pods running. And if I'm going to talk about service in a second, but imagine my traffic are still coming in and it's being basically randomly chosen one of the 6 pods that's running. Excuse me. So next, what happens is, you know what, I have 5 running, so I'm going to kill 1, make it 4, and spin up 2 now. I still have 6 copies running, and application is still being distributed back and forth. And then I'm going to kill this, have 3 running, and 3 running. And again, it could be 3, and could be that since I said I don't want any less than 4 or any more than 6, this could be that this was actually 2. But this is still fine. This still satisfied my need that I wanted. Then let's say I have like 2 running, 1 running, eventually nothing running. And on the other hand, this will eventually go to 3, 4, 5. And then I only have 5 of them running. That's a rolling update strategy. And you could do any combination. You can say, you know what? I don't really care if I spin up more pods, but I want none of my pods to go down. For example, I always want 5 or more. So you could say, you could max surge. You could surge up to like 75%, but mean you can only go 0. So basically, you'll never go lower than 5, but you can go up to like 8, 9, something like that. So that's rolling update, and depending on what your need is. For example, if you're doing a breaking change and you want everybody to just like switch immediately, even if you have a downtime, you don't care, there are ways to do it in the cutoff deployment strategy. What cutoff does basically kills all of them first and spins the new one up again. So basically, let's say you had an application, you're a bank, and all of a sudden you found a bug that people who are doing negative deposit are getting money in their account. I don't know how could you be a bank if you had that problem? But let's say something like that happened. You don't want a rolling update. You don't want even one person to fall through on the version 1. So you want to just kill version 1 and spin up version 2. So you probably want to do cutoff like that. So that's deployment. Then I think the primitive that is probably the most useful among all of them, although, yeah, I'm going to call it the most useful, is service. So what a service is that you wrote your application, deployment, pod, replicas, and all that stuff. They're still internal to your cluster. No one from outside has any access to that thing. The way people get access to your application is via a service. A service basically uses one of many ways to expose your application from internal to external. So the first one would be node port. Node port is basically, let's say you have multiple nodes. Each of those nodes has a public IP. Node port basically opens up one of the higher ports, like 3,000 or above, 30,000 or above port, and just port forward that to your application. So node port is not the best way to do it because first of all, it's a static port that you have to use. Second of all, you're using like one of the nodes. So it's not for production, it's for testing if your application works or not. The next one is load balancer. Load balancer is pretty great. You open up, you get like static, like one public IP for your application. It's pretty great. But the problem with load balancer is no matter which cloud provider you're using, load balancer costs you a lot of money, right? So load balancer basically each application gets one static IP that your cloud provider is giving you, and depending on who you're using, it can cost a bunch of money. Sometimes you even have some sort of like quota on how many load balancers you can even buy for your cluster. Like some provider can give you like a max 20 ports or even 5, like I don't know exactly what number, but load balancer is great, but it's expensive and not always available. The one after that, I think, is called Ingress. So what Ingress does, it basically takes one load balancer and then uses like a domain name for your cluster. I think you use Ingress for your application, right?
Yeah.
So Ingress, you can use the same load balancer then to use multiple paths to reach your application. So you can almost like multiplex your load balancer.
Gotcha.
To basically, if you have 5 applications, you can use the same ingress but in a different path to point to a different part of your application. That
Gotcha.
way you can just like use the same load balancer for multiple things. Ingress is not probably the most robust solution, but it's probably the best one out of the box on vanilla Kubernetes you have. Many people have done other things. For example, they create their own ingress using Nginx with like F5 load balancer on top, things like that. You could do that. There is a pretty cool solution that comes with Openshift. If you're an Openshift user, so Openshift is kind of like taking Kubernetes but wrapping it into like a PaaS solution. So Kubernetes is more like a container as a service solution. You have to do a lot of the work yourself. Openshift, it takes it more towards the PaaS side. So from an application developer point of view, you just write your application, put it on Openshift, it just does whatever it needs to do. Then it gives you certain things, like it gives you things like a route. Route is, I would say, ingress on steroid, almost. It can create individual route, but from your point of view, it looks like a unique web address, like a domain, but underneath it's still using load balancer, but it just makes it a little bit like easier to manage. You just click get route, it'll create a route for you. It has a lot of, it's much user friendly, if I had to say. Okay.
Gotcha.
But again, OpenShift underneath uses Kubernetes. It doesn't do anything crazy magical, but it just wraps everything into nice packages. Same way, like you could use an operating system completely from a terminal, but sometimes having something to click is easier.
Right.
Similar idea. Like same way you can install a Ubuntu system without installing a GUI, and you can do everything from the terminal.
Right.
But
So OpenShift is kind of just like a GUI for Kubernetes.
Yeah, OpenShift, you can do everything in OpenShift as well from terminal, but like OpenShift kind of like brings the gap down.
Kind of in like a higher level API.
Right, if you want to just,
Okay.
we're gonna take a quick look at what OpenShift looks like in a second. But so it kind of brings the gap down from what can you do from a GUI from what you can do from a terminal. On Kubernetes, they have like a terminal as well, but the terminal is not as robust to the point you can say, you know what, I don't even need to touch the terminal. I can just use the GUI all day. But in OpenShift, you can make that choice. You can say, you know what, I can use the terminal or the GUI. It doesn't really matter. So you can have 2 people in the team. One of them, let's say, is a terminal expert, lives in the terminal. Other person is the GUI. They can work together still because all the things are one-to-one available on both sides.
Gotcha.
Which is pretty excellent. So again, enough talk. I think I have to like quickly show a couple of things in Kubernetes. If my terminal, okay, there you go. Oh, okay. I think my terminal iTerm wants to update, but I don't want it to update. Okay, here we go. And this is back. All right. I was playing with OpenShift a couple of days ago. These are just aliases. These are not actual commands. So this is basically saying IBM Cloud, Kubernetes service, cluster config, and this. So in one command.
Oh, nice.
Yeah, I got like. So there is also like a video on YouTube. It's like a 5-minute, very short video by Spencer. It says like stupid bash tricks with Spencer. So Spencer is kind of like a master of like bash scripts, bash commands. He, like on YouTube, actually, you know what? I want to show you. It's amazing. Oh, someone subscribed to us. Thank you. Let's see if I can find it. Oh yeah, 20 bash tricks in 5 minutes. Or just like if you just Google Spencer Crumb, these are like the first couple of videos. This is the best. We should definitely watch this. And he does like crazy bash aliases and scripts. For me, it's much easier, simpler stuff. I mean, basically, I would have to type in IBM Cloud, KS, cluster, config, Mofi K8s. I just made it easier for me. Anyway, so I have this Kubernetes cluster. Again, kubectl for me is the same thing as KL. I just aliased it again. API resources. So I just wanted to quickly show you all the different API resources that comes built in with Kubernetes. I have a couple of extra here because I've installed Knative and such. But there are some of them are like pretty built in. For example, config maps is a way for you to store environmental variables that you can pass to your application. Nodes, we all know, nodes are there. Namespace is a way to isolate work based on certain criteria. For example, each of your application could be in a separate namespace, and that's the way Openshift does work by default. But Kubernetes doesn't really decide that for you, but Openshift does. But namespace is basically, let's say, you and I are working on the same cluster. So you get your namespace, I get my namespace, and then the cluster admin, in this case is someone else, not any of us, can set up some limit on each of the namespace. That way you don't go over your quota, I don't go over my quota, and I have my IPs and all that stuff separate.
Gotcha.
So that's what namespace is. Events is, again, it's pretty useful for debug. Everything that happens in Kubernetes is like stored as an event. What else? Persistent volume claims and persistent volumes. So on Kubernetes, you have certain things called PVs. These are like storage that you can use for other things. And the volume claims is, let's say your application makes a claim to use a persistent volume. That's a volume claim. And this depends on how much storage you have in your cluster. You can also do external persistent volume, like a bucket, storage bucket, and things like that. There work being done to kind of like standardize the persistent volume system. It's not done, and when it gets there, it'll be pretty great. Resource quotas, again, each of your application can have certain quota. This application has this much RAM, this much CPU, and things like that. Secrets, as I said before, you don't want to, secrets are the way Kubernetes stores this data, but you don't want to store secrets directly like this. Next is service accounts. Service account is basically figuring out who you are. So you can create a service account and give the service account, let's say, you have a private Docker registry or things like that. So service account can use that to pull that private Docker image for your application. There are a bunch of other daemons. We talked about deployments. Daemon set is basically like deployment, but it makes sure that one copy of the application always runs on each of the nodes. Doesn't matter how many nodes you have. Replica sets we talked about. What else is there? Cron jobs. Cron jobs, it's coming from pure Linux. It's a job that runs on a specific time. Jobs are like cron jobs, but it runs whenever you run it. Images are, this is from Knative. We're not going to talk about this for now.
What is Knative?
So Knative is a project that runs on Kubernetes, but it gives certain added benefits on Kubernetes. We're going to have a whole different talk on it. Let's not dwell on it right now. It's pretty cool technology, but it's added. It's like an add-on on Kubernetes.
Gotcha.
We talked about pod. We talked about ingresses. Network policies is basically a little bit like higher level primitive, but you think of this as you can set certain policy based on who gets to talk where. And you have all these other things. On the bottom, I have some Tecton stuff. These are also like add-on like Knative. So on Knative version 8, they got 0.008. They got rid of the build on Knative. So Knative had serving, build, and events. They got rid of the build, and they suggest using Tecton. So we're going to talk about that in the future, hopefully. RBAC, right here, you can see some RBAC stuff. Cluster role binding, role binding, and role. Hello, Kenyan. Hi. So the cluster role binding is, so RBAC are role-based authentication control. So based on your role, you can set certain authorization. Let's say with your user role on your namespace, you can create pod, create deployment, create service, but you can't delete a namespace. I can create that role. That way, let's say you and I both are on the same cluster using same namespace, different namespace, and you go like, you know what, Mofi's been using too much of the resource, I'm going to delete his namespace.
Gotcha.
From if you're an admin, you have access to everything. Your admin role can do everything on the cluster.
Gotcha.
But so you can create a little bit lower power role. Basically, just like any user authentication you create, you don't want everybody to be admin. You want like lower level, right?
Makes sense.
Yeah.
I have another question.
So the question we have is, how would one do versioning on your deployed app APIs which need to be backward compatible? That's not as much of a Kubernetes question as much of a like, how do I like version my APIs? But I mean, that's like a pretty, I mean, first of all, if you want backward compatibility on your APIs, you probably want to create the APIs in such a way where you don't change your APIs, like, what do you call that thing? Interface, right? If you don't change your API's interface, it shouldn't necessarily, it doesn't really matter if you're running on Kubernetes or anywhere else, it should be fine. But even with that, you can, on your ingress, you can then do things like, in the path, you could do things like V1, V2, and tell users to use V1 or V2 based on what they should want to use, and eventually say V1 will be sunset at some point. That's the way, I mean, I think GitHub did their APIs. So right now, if you look at GitHub APIs, they're on V3. But initially, when they started, they had V1 and V2. And when they first moved to V3, they had V2 still available. But eventually, they got rid of V2 completely.
Right. Yeah,
so,
and that's similar with like our IBM services.
Yeah.
Like
so we have versioning also by date. We have version, like we have certain, like every certain month, we release a new version with a new date. And we tell users to use this, but the older date is still available for a certain time. So short answer, if you want backward compatibility, don't change the interface of your API. If you have to make breaking changes, let the user eventually move on, like so that it doesn't really break their application directly. Yeah, I don't think Kubernetes itself can give much better answer on this problem. It's more of a like application design problem rather than like a Kubernetes thing, right? But the cool thing about Kubernetes is you can run multiple versions of the application at the same time. I mean, it's not necessarily unique to Kubernetes, but you can do it much easily in Kubernetes. So you could have multiple versions running at the same time, and if each of them have the same interface, your application user and end user wouldn't really see the difference for the most part. And if you want to have fine-grained control about who gets to see something, that is, I think we're reaching the service mesh territory, where you can control based on, let's say this user is a beta user, or like if they signed up for experimental features, let them see the new like V3 version that no one else gets to see. Things like that. Now we're like kind of like getting into service mesh territory. But I mean, feel free to ask more questions or find me on Twitter or something. We can chat a little bit more about for your specific problem. But in general, if it is like API versioning issue, I think you have to use your best judgment what makes sense for your application for the most part. I also promised we were going to talk a little bit about Openshift. So we're going to look at Openshift cluster. Given my,
I use Openshift for my thing since I don't know what I'm doing.
Yes, but also like again, I honestly don't even think you needed Kubernetes to begin with. You had one.
I could probably just do it just some Docker.
Or Cloud Foundry even. You don't need Docker.
There was underlying reasons why I couldn't use Cloud Foundry,
I see.
and that was the way my app interacts with the object storage and the servers that are used.
I see. Okay. That's my OpenShift cluster. You can see the red circular logo denoting it being the OpenShift cluster. Do I really have 0 worker nodes? That's sad. Oh, I don't. No, okay, good. So again, OpenShift gives you a pretty nice interface for you to do things. Also, it comes with certain, it's not a build pack per se, but it's kind of like, they have a thing called S2I, source to image. So if you try to Okay. So I think you were talking. Okay. I see. So I think the question Kenyan had was more towards the line of image version. So image version tag 112. I mean, again, Kubernetes, you basically just use it in the deployment YAML. You say exactly which image version you have to deploy. So in Kubernetes, when you're deploying a new image, you can say things like pull the latest all times. But latest actually is not the best way to do it, because latest can mean a bunch of different things, because latest could be the last thing you pushed. It couldn't might so you ideally want to use exact version number you want to use. Some people like even use their commit git SHA or even the Docker image SHA. So you could use that. When I push an image with 1.2, it won't get pulled once the pod is restarted. Yeah, I mean, if you have hard-coded like a tag number on your deployment saying for this image use version 1.1.1, Kubernetes will not go out of its way to download 1.1.2. So, so even just because you pushed a new image doesn't necessarily mean Kubernetes will change its own version. If you use latest, Kubernetes then, if the pod gets restarted, Kubernetes, and if you have image pull policy as always, Kubernetes then will say, you know what, I need to pull the latest image, try to pull the latest. You can also set things like if not present as your image pull policy. Then Kubernetes says, you know what, this node already has an image with the tag latest, although this latest could be 6 months old, but I already have the image, I'm not gonna pull it. So you can do a couple of things that way. Okay, so next, so in here, right, so you have this bunch of different types of application that you can build, and you can just like point Openshift to a Git repo. It doesn't even need to have a Docker file in the Git repo. It just knows it's a node application, and from the node application, yeah, no, I think Kubernetes doesn't really do 1.1.x to always keep pulling on one. And another thing is, in a deployment pipeline, again, we're going to probably have like a nicer example at a future, like a talk. But what you want to do basically, let's say you push something on your Git, then your pipeline takes over, builds the image, pushes to your Docker registry, wherever that is. And that Docker registry push kicks off a new event, then takes that Docker image name, goes to your deployment YAML, changes that deployment YAML with the new thing. That change kicks off another pipeline that goes to your Kubernetes cluster and deploys that new deployment YAML. Sounds super convoluted, but once you do it, it's actually pretty straightforward.
Right, I think that's what I'm doing pretty much. Yeah.
So it's pretty straightforward. Yeah, so Kubernetes doesn't really do this wildcard matching for its image name just yet.
Are there like other services that do it for you? Maybe?
So there are some services like Helm can do like a version upgrade automatically like this. Okay. You have a question I'm going to ask first in a second. Like one of my mentor actually asked a question, and he saw the service, we saw our video, which is amazing.
Nice.
But I'm going to ask you in a second. But
okay.
Okay. So again, you just point it to like a Git repo, and that Git repo doesn't even need to have a Docker file in it. For example, this Git repo, this is a test repo, doesn't have a Docker file in it, but all you're gonna do, we're gonna go next, you're gonna say try sample repo, node.js ex, and I'm gonna say create project. I'm gonna give the project name node test. Yeah, so Helm is pretty cool, and Helm actually is having, so Helm, the issue with Helm, again, I think I told you not to use Helm before, is because Helm requires something called a tiller to run on your cluster. With the new version tiller needs to get like full admin access to your cluster. With the Helm 3 that's coming out in like a couple months, it's not gonna require that anymore. They got back together and wrote the application better probably. So they no longer require it. So Helm is definitely something to check out, and Helm can be a big part of your pipeline because Helm can auto version, it can roll back and it can do a lot of cool stuff. So I'm gonna create this project, and it got created successfully. That was deceivingly fast. So again, so it's now doing the build, and you can see all the build is happening in Kubernetes because Openshift has like builder built into it.
Right. So just like a quick recap, you pointed to a Git repo, and it's gonna like clone into it and spin it up.
So it's gonna go to the Git repo, clone the Git repo, look at what kind of application it is. If it's Node, they have something called the image builder.
Okay.
It will use the image builder to build the Node image, push the Node image into a private registry that's running in the cluster. Right, and then after push is successful, it's gonna then spin up
a nice little pod.
It will spin up a deployment pod, and it will also give you a route already set up. And if I click this, the application is running. So all I had to do was say like, that's my repo. Bam, I moved on, right? This kind of cuts down a lot of the things you were doing to be able to get like image pushed, deployment pushed, all this other stuff.
I was skeptical, but that was pretty nice.
Yeah, I mean, and if like the language they support by default is not what you want, you could technically have a Docker file just sitting on your repo. If it doesn't match any language, it'll just use the Docker file.
Okay.
It'll always fall back. If you want to write your custom STOI, they have instruction on how to do that as well. I used one for, by default, as you can see, they don't have one for Go by default, which is sad. Given Kubernetes is written in Go, they don't have. But again, there are instructions how to write one yourself for Go, and you can just like, you can get a nice little like a click deploy for Go as well, if you want, or any language. That's your choice. Like if you want to spend the time in writing an STOI for COBOL, go for it. I'm going to actually tell JJ to write one because JJ is a big COBOL expert, and he's working on getting COBOL to run on Kubernetes, which is crazy. But that being said, is that like this is the whole, if you want more copies, you just say, I want more copies, click a couple times, it goes up to 3 pods, it's spinning up 3 right now. If you want to create a new deployment, you can do that. If you want to create on the build, if you want to say, you know what, I want my GitHub webhook, so that every time I push something on my Git web page, it should start a build again. You can do that as well. It comes built in with that. So Openshift is sweet. It has a lot of these cool things.
All right, maybe you'll have to set it up for my thing.
We will. I mean, again, that will be so much easier to set up because you don't have to worry about the ingress that we like kind of killed ourselves over.
Don't remind me.
No, I'm not gonna. So again, I think this gave you and our viewers a pretty good overview of what Kubernetes has to offer. Hopefully next time we'll start writing applications for Kubernetes and see the whole pipeline. I will probably show a little bit more examples of Openshift because I am learning it for the first time as well, and it's a lot of fun.
So what's the catch? Like, am I giving up anything going to Openshift? Why should I use Openshift?
So Openshift uses Kubernetes underneath, but again, Openshift is a licensed product. So you couldn't just like spin an Openshift cluster up yourself that you could just manage. You could, but I think you'll still have to pay for licenses.
Okay,
but like
so it's more money involved.
A little bit more money involved. Okay. But if you use a managed Openshift version, I don't think the cost is too different from one another. You pay probably a one-time licensing fee, but again, if you're using a managed Kubernetes, that one-time fee is not gonna like affect you that much.
Gotcha.
Yeah. So with that, I think we're gonna end it here. Thank you all for all the questions, Kinian. If you have any more questions, feel free to ping me. Either here or here. It's not gonna stay here. On Twitter, our Twitter is in the bottom of the screen, as you can see. Like so, Nick and me. Nick is Bordakis1. I'm Moficodes. Find me on Twitter or find us on LinkedIn or YouTube video. This is gonna go up on YouTube in a second. Yeah, please feel free. So with that, I'm gonna end it here. What's to come for next week for convolution, Nick?
Oh man. So we're right. So last week we were using the old-fashioned sort of fully connected neural network.
It was pretty clanky.
It was yeah. But we're gonna start talking about some new layer types.
Okay.
Lots of layer types coming. Mainly convolutions.
As long as I don't have to do the math by hand, I'm okay with it.
No,
Okay,
we won't touch the math unless let us know if you want the math. We can do math.
Okay, excellent. So with that, I'm gonna end. And next week when I come back, well, next week probably won't have a stream because I'm traveling, or we might have a stream. I don't know yet. So we'll figure it out. Even with that. Hopefully, just if you have any more questions or content you'd like to see, both on the cloud native side and AI side, ping us, let us know. Again, we create this content because we hope people are getting some use out of this. So with that, I will end it here. Any final words, Nick?
No.
All right, Nick. Nick usually don't have any final words. That is. So with that, I'll end today's stream. Until next time.